Hi everyone, welcome back to lab. Today we're going to be exploring the different properties of liquids. So far, we have explored the different properties of solids. So do you guys think that liquids have some of the same properties? And what do you think they are? Matt?
Maybe they smell different, maybe they look different, maybe they feel different.
Yes, very good. So up here I have three different liquids, but they all look similar. But they can all have different smells or feel different. Today we're going to investigate the differences between these three liquids. We have mineral oil, corn syrup, and water. In front of you on your desk, you also have the three liquids. So I'm going to give you your worksheets. They have the instructions of what we're going to be doing, and we're going to complete the first experiment together. First, everyone should have three different droppers. You're going to take the first dropper, and you have a Ziploc bag labeled with mineral oil, corn syrup, and water. Pick up the first dropper, and we're going to put 3 drops of mineral oil onto the index card. When you're done, you can put the dropper down, and we're going to do the same thing with the corn syrup using a new dropper. Using a third dropper, pick up a new one. We're going to do the same thing with the water. Make sure you put any excess liquid back into the cup. So if you look at your worksheet, I created a chart that I want you to fill out. You're going to describe each liquid drop. You can talk about its color, maybe the shape of it, what was its size, and write down anything else that you observe. I'll give you guys about 2 minutes. Yes, Matt? Finished? About another 30 seconds. Okay, would anyone like to share some of their observations? Matt?
I noticed the water moves around a little bit as I write on my desk. So I guess that means the texture is different than the corn syrup.
Okay, very good.
I've also noticed that the mineral oil is flat or thinner than the other two liquids. I've also noticed that the corn syrup is probably the biggest liquid of all, and it's definitely thicker because it's not moving around the same way like the water is, and it also has a round shape to it.
Good, those are great answers. I would also say the mineral oil, it's definitely spread out on my Ziploc bag on the plastic. The corn syrup and the water seem to be more round in size. And you're right, the corn syrup is definitely one of the thicker liquids. I would say the mineral oil is thick too, but it just takes a different shape. Okay, so for the next part of the experiment, I want you guys to pay very close attention, and you're going to need the Ziploc bags. Hold each of the corners and slowly lift your bag. Pay attention to how each liquid is moving down the bag. Which one is slower? Which one is faster? And follow how far down the bag the liquid is moving. When you've lifted your bag all the way up, you can place it back down on your desk. I'm going to give you a paper towel so you can clean up any of the liquid that's spilled. If you look back on your worksheets, I want you to record which liquid moved the slowest, which liquid moved the fastest, and which one moved in between. I'll give you guys about a minute to record your responses. Okay, would anyone like to share what they recorded? Matt?
So the slowest liquid for me was the corn syrup. The fastest liquid was the water, and the medium paced liquid was the mineral oil.
Very good. I have the same answers. The water, if you guys paid attention, moved very fast down the Ziploc bag and it immediately fell onto the desk. The oil moved a little slower, but it did eventually make it to the bottom of the bag. And the syrup, it almost barely moved at all, and it still, right now, has not reached the bottom of the Ziploc bag. Now, I want to show you guys a brief video that's going to explain the properties of liquids in further detail.
Hello everyone, today I'm going to discuss with you the special properties of liquid. Liquid is one of the states of matter that flows. It has definite volume but has no definite shape. Do you see this green water flowing from one glass to another? That is called fluidity. Next property is viscosity. Viscosity is the measure of liquid to resist flowing. High viscosity means the fluid is thick. To explain that, I have here three kinds of liquid. I have blue water, olive oil, and honey. I will put in them a marble in each one of them. As you can see, the marble reached the bottom of the blue water first and the marble reached the bottom of the honey last, which means the honey has the highest viscosity and the blue water has the least viscosity. Last property is capillarity. Capillarity is the ability of liquid in a capillary tube or an absorbent material to rise or fall. To explain that, I have here a tissue which I will soak in this red water. As you can see, the red water goes up because of capillary action. This is one of my mother's plants. It absorbs water from the roots because of capillary action. When we cry, our tears from our tear ducts flow because of capillary action. Again, the special properties of liquid are fluidity, viscosity, and capillarity. I hope you understand my explanation. Thank you. Bye!
Grammarly does more than catch errors.
Okay, so can anyone tell me the 3 properties of liquids that we just learned from that video? We learned about the thickness of them, the way they move. Yes,
One of them was, I believe, viscosity.
very good. One of them was viscosity. Yes,
Something with a C,
capillarity.
capillarity.
And there's one more.
Density.
Not density, but fluidity. Fluidity, viscosity, and capillarity. I want you guys just to remember those 3 properties because next class we're going to go into them in a little further detail. And we're going to apply those terms to some of the liquids we have explored today and other liquids in the future. Next, I'm going to ask you guys to come up to the front of the room so you can see this next experiment a little more closely. I'm going to take food coloring and I'm going to add 1 drop into each one of our liquids. I'm actually going to add about another 2 drops just so we can see what's happening a little more closely. Okay. You guys go back to your seats. And I want to know, what did you observe when I added the food coloring to the water, the corn syrup, and the mineral oil? Using your worksheet, I've created another chart, and I want you to record your observations. Where did the food coloring go? What did it do? I'm going to give you 2 minutes, and then we're going to share our answers together. Okay. Anyone like to share some of their answers about the food coloring? Yes, Matt.
So I noticed that with the water, the food coloring sank to the bottom, but it also kind of spread out, I think, a little bit. It didn't just stay in one place. Whereas the mineral oil, it also sinks to the bottom, but it stayed together all in one drop, unlike the water, where it went all over the place. And the corn syrup, it stayed right at the top. It didn't sink to the bottom like the other two liquids, but it spread out like the water did.
Very good. So here's the water, and like Matt said, when we put it in the water, it's completely sank to the bottom and it spread out. If you look in the glass, it almost looks like the whole glass turned yellow. And the corn syrup, like Matt said, the food coloring is completely still on top at the surface, but it did spread out and it did not sink to the bottom. And last, the mineral oil, the food coloring, it fell to the bottom like Matt said, but the drops stayed together. They did not spread out. So we can see that the food coloring acted differently in all of our liquids. So do you think this means that our liquids are the same, or do you think that they're different?
I think they're different.
Right. So if they're different, there must be something different in their properties that makes them all react in different ways to the food coloring. Putting together, today we learned about the different properties that liquids might have. We investigated mineral oil, corn syrup, and water. We observed how the different liquids took shape and reacted on the plastic bags. We paid attention to their form, how they fell down the bag. We also observed how the food coloring reacted in the different liquids. So with that being said, what other properties do you think we could test with these liquids? What could we look for? Yes, Matt?
Maybe how it tastes. Maybe if we put it in our mouths.
Yes. If we were to explore taste though, you would have to use different liquids that might be a little more edible. We could definitely use the water and the corn syrup, but the oil would not be the best thing for us to taste. Any other properties? Matt?
Maybe how it feels.
Okay, can you elaborate a little more on that?
Maybe if we touched it with our hands, or maybe poured it on our hands.
Good. We could definitely explore how it feels, its texture, if it's slimy, if it's wet, does it feel thick, is it smooth, is it sticky? So those are definitely two other properties that we could explore. Before the period ends, I want you guys to take out your iPads, and I'm going to give you a link to type in so that we could play a brief game at your tables about different properties of matter. When you're ready, you're going to type in ABC YA.com /games /states _ of _ matter. When you get to that page, I'll show you guys up on the screen now. You're going to hit play.
States of matter.
And press go.
Matter
is anything that has weight and takes up space. Matter is all around us. 3 common states of matter are solids, liquids, and gases.
I know today we mainly went over the properties of liquids, but this game will be a little refresher since we are already explored solids and gases.
Mass and volume are properties of matter. Mass is the amount of matter an object has. Volume is the amount of space an object takes up. Solids are a type of matter that are hard and take their own shape. Pencils and rocks are examples of solids. Solids have a definite mass, volume, and shape. Liquids are a type of matter that do not have their own shape. Liquids are wet and take on the shape of their container. Water is an example of a liquid. If you put water in a bottle, it will take the shape of the bottle. Liquids have a definite mass and volume, but do not have a definite shape. Gases are a type of matter that do not take their own shape. Gases can smell or be invisible and will tend to spread out to fill their container. Oxygen and helium are examples of gases. Gases do not have definite mass, volume, or shape. Place the objects into the correct category.
So when you guys get up to this part of the game, it's similar to the chart I had on your worksheets today, but you're just going to separate the solids, liquids, and gases as a little refresher.
Propane. That is not a solid. Wood. You got it.
Yeah, the wood. Propane's different.
Air.
I'm gonna say.
Perfecto.
Oh, water.
Water. You got it.
Pencil. I think they
Pencil.
mentioned a pencil is a solid.
Perfecto. Milk.
Definitely. I drank milk in the morning, so
You got it.
it has to be a liquid.
Bananas.
Is a solid.
You got it.
See, I got this wrong last time. I thought this was
Propane.
a solid, but I think it's a gas.
You got it.
This ice cube, this is tricky. I can grab it, but I know ice is made of water.
Ice cube.
I'm going to say it's a solid. Oh,
Perfecto.
good, I got that.
Juice.
I drank juice in the morning.
That is not
Oh.
a
I
solid.
dragged it to the wrong place. Whoopsie.
Water vapor. Perfecto. Rock.
Oh, rock is definitely a solid.
Perfecto. Helium.
Well, they're showing me a balloon is a solid, but
But
I
what is
think
in
what's
the
inside,
of the balloon?
I think, is helium, which is a.
Perfecto.
See, I put this in the wrong place before.
Juice.
Fix that.
You guys, job.
There we go.
You
All
sorted
points.
all the solids,
All right.
liquids, and gases.
The bell is just about to ring. You guys can leave all of your materials on the desk. I'll clean it up to avoid any spillage. And before you leave on your way out, you can hand me your worksheet. And I'll see you guys next time.